This episode explores how artificial intelligence will solve entire disciplines like math and physics within the next 10 years. We break down a 5-level scale showing how human work shifts to artificial intelligent industrialization and outcome-based economics. Experts predict that real-world assets will follow suit as technology transforms financial infrastructure and global markets. The conversation begins by referencing a previous episode on technology becoming too cheap to meter. That idea blew minds and opened new perspectives. Since then, the speaker co-authored an online book titled Solve Everything with his friend Peter Diamandis. The central thesis argues entire disciplines are about to get completely solved by AI. Mathematics is largely considered already bulk solved. Physics remains a primary focus for the company Physical Superintelligence. The goal is to map how society moves towards circa 2030. When asked to define solved, the speaker offers an operational definition. It means having a framework where we can scalably pour compute into the system. If enough compute is poured in, a solution will come out. This represents an industrialization of the field. Mathematicians create unsolved problems when researchers spot patterns and speculate on their existence. Some remain open questions like Fermat's last theorem, which took centuries to solve by Andrew Wiles. We are moving from a world where centuries-old individual problems get artisanally solved by experts to one where AI bulk solves many problems. Problem identification is also going to get bulk solved. Anyone holding that belief regarding the economic impact is wrong. Bulk solution to math is not the most economically transformative field. Physics gave us transistors, lasers, and nuclear energy. Math serves as the canary in the coal mine for broader technological shifts. It suggests that math was simply the lowest hanging fruit. He reflects on his own history, recalling the early 2000s when he finished undergrad at MIT. He started a PhD in physics at Harvard. His favorite problem was molecular nanotechnology, inspired by Eric Drexler's engines of creation. He envisioned molecule-sized nanorobots that could compute and self-replicate. Yet, he notes with disappointment that molecular nanotech has not made the progress he would have liked. The conversation shifts to financial infrastructure. Trillions of dollars in real-world assets are stuck off-chain. Real estate, commodities, private credit locked behind outdated systems. Ferris is presented as a Layer 1 purpose-built for RealFi. A $10 million incubator backs builders who want to make real a reality. Back to the core discussion, he speculates on future problems but refuses to reveal them just yet. He notes that Google recently claimed 75% of their code was written by AI. Meta also laid out plans to fire people because of AI. The bottleneck is real, and data centers are being built in space. He defines a scale from L0 to L5 to standardize the process. L0 is the ill-posed stage, where people do not agree on rules and data are messy. Humans drive everything relying on intuition. At L1, a field becomes measurable, allowing for consensus and benchmarks. Progress moves to L2 as the repeatable domain. Humans follow scripts similar to commercial flight checklists. Then L3 arrives as the automated domain. Tedium is handed over to machines, and humans move up the stack. Humans transition from operators to managers handling exceptions. An example would be modern call centers where humans talk to chatbots. Then we arrive at level 4, which is the stage where a field becomes industrialized and buyers stop hiring humans to do tasks entirely. Instead, they are paying for outcomes. They're paying for outputs, not inputs. The economics of the field start to change in favor of AIs. It makes more sense to have AI run the show. The role of humans becomes one of auditors or system architects, ensuring that the intelligent machines run safely. We see that in modern factory assembly lines where humans, by and large, are not artisanally hand-building cars anymore. Then finally, at the top of the ladder, we get to level 5, where a field has been solved or commoditized. As defined earlier, the solution of a field means we have a reliable way to turn solutions into compute-bound problems. If you want better output, you just inject more compute as input. It's compute limited, no longer human limited. At that point, the human role is one of consumers. We consume the output without needing to think much about how it was made. The role of AI becomes almost invisible, like a utility in the background that's generating results at scale. So gene sequencing looks somewhat like that at this point. The broader point is the ladder from level 0 to 5 is about to sweep across a range of disciplines. It's going to wash over the entire economy.